Well, this is interesting. I like this one. Equilibrium constant of the following reaction for the decomposition of phosgene at 25 degrees Celsius is this. So again, we're given a Keq, and so we're going to be asked something about either the reactants or the products. When the equilibrium concentration of CoCl2 is this, what are the concentrations of CO and Cl2? What? Two unknowns? But we only have one equation! What are we gonna do? Well, there's this last part. Assume the concentrations are equal, which is a reasonable assumption, right? If you started out with 1 mole of this and you lost, like, let's say 0.5 moles, you would expect to gain 0.5 moles and 0.5 moles because everything is in a 1-to-1 ratio. So if I write out my equilibrium expression, Keq equals concentration of CO to the first times concentration of Cl2 to the first over concentration of CoCl2 to the first. All right, so now I'm asking for the concentrations of these, and I'm assuming that the concentrations are equal, meaning I could put this in as a variable. I could say concentration of CO is X, and the concentration of Cl2 is also X. Lovely. Okay, now I have one unknown, which is X, even though it stands for two different things, but I have the rest of the information that I need. I just need to multiply both sides by CoCl2 to isolate the x's. So what I get here is I get x squared equals concentration of CoCl2 times Keq. All right, and notice that this is squared, which is not what I want again, so I need to square root both sides. So x equals the square root of concentration of CoCl2, 0.00370 times the Keq, 4.282 times 10 to the minus 2. And from this, I get 1.26 times 10 to the minus 2. Now I've got to add unitin. We're talking about concentration, so it's going to be molar again, okay? Because this one's molar. That's it. Nice and easy.